Welcome to The Explainer. We're going to dive right in today, and we're going to do it by looking at the blueprint of a single university course. Why? Because we want to answer a pretty big question. What does it actually take to build a modern engineer?
So, what's the secret sauce here? Is it just about cramming your head full of theories from a textbook for hours on end? Or is it something a little more hands-on? Something a little more real?
Well, to figure that out, we're not going to just guess. We've got the real deal right here, the official syllabus for a core engineering course from the SRM Institute of Science and Technology. So let's crack it open and see what it tells us. All right, so the course itself is called Microcontroller, and this isn't just some elective you can take for fun. Nope, it's a professional core subject. That means it's absolutely fundamental for anyone studying electrical and electronics engineering.
And right from the get-go, the syllabus lays out exactly what this is all about. And I want you to pay close attention to the words it uses here. It doesn't just say you'll know stuff or understand stuff. The key verbs are experiment, design, and build. That kind of action-oriented language, well, that really sets the tone for everything that follows.
So where do you even start on a journey like this?
Well, it's just like any big engineering project, right? You've got to start with the fundamentals. You can't command the machine until you learn to speak its language. And you can see that the theory is built up in these really logical layers. First, you get to know the machine's architecture, its brain. Then, you learn its native tongue, its own language. And only after that do they hand you the cool, modern tools, like the Arduino platform. That's what lets you build a bridge from just pure code to the actual physical world of sensors and motors. But look, all that theory is just potential, right? It's just sitting there. The real question, the one that matters, is how do you turn all that knowledge into something that actually works? And the answer, of course, is simple. You get your hands dirty in the lab. This right here, this is the magic moment. It's that critical turning point where all those abstract ideas suddenly become real, something you can touch. It's where a few lines of code actually make something in the real world light up, or spin, or take a measurement. And just look at the stuff they're building. We're not talking about simple blink and LED exercises here. No way. They're creating actual home lighting controls, systems to measure temperature, and even, get this, automated solar panel trackers. Every single one of these is like a mini project that solves a real problem. Okay, but even those cool lab experiments, they're not the final destination. Think of them more like training, practice for the main event, because everything you see here is building up to one thing, the capstone challenge. And as we dig into the syllabus, it becomes pretty clear that this is the true heart of the entire course. And this number right here just says it all, a massive 60 hours. 60! That's how much time is dedicated exclusively to lab work and that big final project. I mean, that is a huge commitment to hands-on learning. It totally dwarfs the time they spend just sitting in lectures. And check out how these structure the project journey. It's basically a perfect simulation of a real professional workflow. You're working in a small team, and you have to take an idea from just a concept on paper, all the way to a prototype that you can actually show off. And then, you have to document the whole thing, just like you would on the job. But here's where it gets really, really interesting. Success in this project, it's not just about did the circuit work or did the code run without errors. Nope, there's this whole other layer they have to think about. They're actually required to think like real engineers, which means dealing with a whole bunch of real-world constraints. Things like, can we actually afford to build this? Is it sustainable for the environment? Are there any ethical issues we need to worry about? It forces them to solve problems not in a perfect vacuum, but within a messy, realistic, and complex framework. Okay, so you might be wondering, if the whole point is to build and apply your skills, how in the world do you grade that? Does it all just come down to a single, big, stressful final exam at the end? Well, this chart tells a pretty powerful story, doesn't it? A full 60% of your grade comes directly from that project you build. Another 20% is for the report and the presentation about it. So yeah, the project isn't just part of the grade. For all intents and purposes, it is the grade. And that brings us to what might be the single most shocking number in this entire syllabus. The weightage for a final written exam is, drumroll please, 0. Yep. 0%. It sends a crystal clear message, right? In this course, what you can actually build is infinitely more valuable than what you can just memorize for a test. And you can see this is a very deliberate choice in how they teach. The little unit tests along the way, sure, they check that you've got the basics down, the remembering and understanding.
But the project, the main event, that's all about testing the highest levels of thinking, being able to apply, analyze, evaluate, and, most importantly, create something totally new. And just in case there was any doubt about what they're trying to do here, the syllabus just spells it out plain and simple. The entire way they grade you is designed to prove one thing and one thing only, that you can hit that final course outcome, that you can actually design, develop, and show off a real project, all while dealing with realistic constraints. So when you step back and look at all the pieces, you've got the theory, the lab work, that huge project, and the unique way they grade. What does it all add up to? What is this process actually building in a student? The big takeaway here is that this is a model completely centered on learning by doing. It's totally project-driven. It's all about valuing skills over just memorizing facts, and it's designed from the ground up to prepare students for what it's really like to be a professional, working in teams and juggling all those complex, real-world factors. What a structure like this really does is it basically transforms a classroom into a miniature version of a professional engineering environment. It's almost like a compressed apprenticeship packed into just one semester. And the funny thing is, the entire philosophy was hiding in plain sight this whole time, right back at the beginning in the course rationale. It confirms that the whole point, from day one, was never just to learn about engineering, it was to learn how to be an engineer, and you do that by building something real. So that leaves us with one final, big thought to chew on. If this is the blueprint for just one course, what happens when an entire generation of engineers is trained this way? What does the future of technology look like when education becomes less about what you know and way, way more about what you can create?